In question 1, we're looking at data from 60 students who have been asked to draw a 20-degree angle without using a protractor. So the data has been collected, and you can see here you've got some students who drew here 30-degree angle, some students drew the correct angle of 20 degrees, and one student up here drew an angle of 48 degrees. But you can see all the information has been recorded and presented in this box plot. And to start off with, we've got a couple of fairly straightforward questions. First of all, we're asked to find the range of the data. So the range is just going to be the largest value, which is this outlier here of 48, minus the lower value, which is 9, and that is going to give us a value of 39. The interquartile range, remember then that the left-hand edge of the box is Q1, or the lower quartile, and the right-hand edge of the box is Q3, or the upper quartile. The interquartile range is Q3 minus Q1, or the upper quartile minus the lower quartile, if you prefer. Either way, that is going to be 25 minus 12, just looking at these two values here and here, which is going to give us an interquartile range then of 13. Part C then is a return to linear interpolation. So this is probably the first question where you have a chance to get a little bit awry. We are given here the information on students who have been asked to draw a 70-degree angle, and we're provided with the results in the form of a table. So we've got 6 students here who drew an angle actually between 55 and 60 degrees instead of the one they were supposed to, etc., etc., etc. And we're asked to find, or to use linear interpolation to estimate the size of the median angle drawn, giving our answer to one decimal place. So the key thing here is to start off with a diagram to help you figure out what's going on. So we need, first of all, to figure out where the median is going to be. So we know from the previous question that we have got 60 students. So if we want to find the middle one, 60 over 2 is going to be 30. So we want to find the 30th student. Now we can see that the first 6 are in here. So if you wanted to do a little CF table column here, you could do, you don't need to. So this is going to be 6. So the first 21 are going to be in here. So therefore the 30th result is going to lie somewhere in this class interval here, because the first 21 are here, so the 30th will be somewhere between 65 and 70, but we're not quite sure where. So what we can say then is that it's going to be somewhere between 70 and 65, and we can see that the first 21 are taking us up to this boundary, and then the first 34 are up to this boundary. So if we're looking for the 30th result, we're going to be somewhere broadly up here. So we can just mark that on with an M for the median. And you should remember then that using interpolation, we can find the value of M by recognizing that the proportion here, the median, is the same proportion through this class interval as the number of students. So we can see that up until this boundary here, so up until 65 we've got 21 students, and up until this boundary here, 70, we've got a total of 34 students. And we also know that the median result is the 30th student. So in effect we're using the ratio here, saying that the ratio of this distance here, if we call that A, to this distance here, so we can work out that ratio. In effect, we're using that to calculate M, because we're saying M, this value here, will also be in the same ratio. So what we're going to do then is this distance here is going to be M minus 65. So this distance as a proportion of the total, which is going to be 75 minus 60, will be the same in proportion as this distance, which is going to be 30 minus 21 over the total distance here, which is going to be 34 minus 21. So we're going to have M minus 65 over 5 is going to be equal to 9 over 13, so we can rearrange that to get m is 65 plus 5 lots of 9 over 13, which is going to give us 68.5 degrees, correct, to 1 decimal place. For part D, we're going to be using essentially the same technique that we just used, i.e. interpolation, but here we're trying to find Q1. So again, we've got 60 students, so if we want to find Q1, or the lower quartile, we're going to divide by 4, and we're looking for the 15th student. The first 6 are in here, and the next 15 are in here. So we are going to be looking somewhere in this class interval here. So again, we can draw our line here, and this time we know that we've got the lower boundary is 60, the upper boundary is 65. We're going to have the point here Q1, and we can recognise that the number of students up to this boundary is 6. The total number of students up to this boundary is going to be 21, and we're somewhere sort of broadly in the middle, and we know that that is going to be where 15 is. So again, we are going to be looking in effect at the ratio of this distance to this distance in both instances. So if we do Q1 minus 60 as a proportion of this total distance here, 65 minus 60, that is going to be the same as this distance here, 15 minus 6, in proportion to this distance here, which is going to be 21 minus 6. So that's going to give us Q1 minus 60 over 5 is equal to 9 over 15. We can rearrange that to establish that Q1 is 60 plus 5 lots of 9 over 15, which is going to give us an answer of 63 degrees. In part E, we're asked to show that there are no outliers, and we're helpfully provided here with the information that we need to find an outlier. So here we're going to use the fact that an outlier is defined as something that is more than 1.5 times interquartile range above the upper quartile, or more than 1.5 times interquartile range below the interquartile, below the lower quartile, sorry. So you can see in both instances we need to find the interquartile range, which we said earlier was Q3 minus Q1. Now, in the information we're provided here the upper quartile. We're told that Q3 is 75, and we've just found in the previous question that Q1 is 63. So the interquartile range is 12, and now we can calculate whether or not we've got any outliers. So let's start with the lower quartile. So if we do 63 minus 1.5 times 12, we get 45, so that's using this essentially here. And we can see that the lowest value according to data is actually 55. So there are no outliers there because our lowest value is greater than this critical level here. Similarly, then we need to do the same thing. Look at the upper boundary. So if we do that, we're going to have 75, which is the upper quartile, plus 1.5 times 12. And if we do that, we get an answer of 93. And similarly here, the upper value, or the highest value that we have here is 84 degrees. So we don't exceed that. So there are no outliers. We're then asked to draw a box plot for this data below. So the key information, we said the lowest value was 55, so that's going to be here somewhere. We are also told that the upper value is 84, so that's going to be here somewhere. The median we have already established was 68.5, which is going to be here somewhere. And then we just need the lower quartile, which we said was 63. And the upper quartile, which we said was 75. So we can then draw the box and the whiskers, and this is going to be our diagram. Finally, in part F, we're asked to state which angle the students were more accurate at drawing, and we're asked to give reasons for your answers. So we've got both the box plots, so this is 20 degrees and this is 70 degrees. And what you want to do here is compare, first of all, the interquartile range. So if you look at the interquartile range, which is essentially the length of the box, you can see that the interquartile range is smaller for the 70 degrees. So we can see here that the interquartile range is 12 from the box plot versus 13 here. So the interquartile range is smaller. And also we should be able to see that with the 70 degrees, so we've got here the median is 68.5, which is just going to be 1.5 away from the median, whereas in the 20 degrees one, the median here is 16, which is actually 4 away from where it should be. So the median is closer to where it should be with 70 degrees. So for both those reasons, i.e. 70 degrees has a smaller IQR, interquartile range, and also the median is closer to 70 degrees. So for both those reasons, 70 degrees is more accurate.